Okay, in this first video, I'm just going to show you how to draw the free body diagram for our friction force investigation. So just note that this block that's on the ramp is going to be accelerating up. So there's a net force acting on the block. So this net force acts in this direction, and I will label it F net 1. Likewise, the hanging mass, what I'm calling M2 in my drawing, it's going to be accelerating towards the floor, and I will denote that, and I will label this vector F net 2, and it goes down. Alright, so now we need to label the forces that cause this system to accelerate like this, and we start with the big one, which is gravity. Gravity goes from the center of the object, which I'll denote with a little dot, straight down to the center of the earth. And I'll label this W sub 1. Alternatively, you could label it FG sub 1. IBO does not care what you label your force vectors as long as it's easy to understand and accurate. To oppose, the normal force is what keeps the object from falling down through the ramp. So we'll label that. And I'm going to extend the line below the ramp. That way when I break this weight into its parallel component, it'll be easier to draw. And then this is my force normal, F sub n, or you can title it R. Now this is just the component of gravity that gives rise to the force normal. It opposes the force normal. So part of the weight or the force of gravity on M1 goes down through the ramp, and the other part actually is parallel to the ramp. So I'll draw that here. This component of the weight that's parallel to the ramp, I'm going to label it W parallel. These two parallel lines, and it's very important. This is the component of gravity that actually sends or tries to send the object down the ramp this way. Note that I have an angle here. Please over-exaggerate the angle. I know in the lab we use 25 degrees, but to see a clear picture, I need you to exaggerate this angle. And because the normal force is always perpendicular with the surface, the angle between this component of the normal force, or this component of the force of gravity, and the gravity itself, the weight, these angles match. Okay. Not only is there the force normal, the weight of object 1, this parallel component of force, but there's also friction. So this is friction force, and I'll label it here. Now because the object is accelerating this way, you know that friction always opposes the direction of motion. So I draw it opposite to my net force, and I can label this F sub F for force of friction. And last but certainly not least is tension. Tension in the string that brings the object up. This is the exact same tension as this object, as the string on this side. So these two tensions, though they're in different directions, they have the same magnitude, and they're part of the same force, and they're connected. I mean, it's the same string. F net, or my mass 2, that also has gravity acting on it. So I just add a little dot, and I'll extend this line straight down, and I'll label this W sub 2. Alright, so we have our weight for mass 1, force normal, this component of gravity that gives rise to the force normal. I'm not really going to label it though. I have the parallel component of the force of gravity down the ramp, force of friction, tension, net force on the mass 1, tension for my hanging mass, the weight of the hanging mass, and the net force on the hanging mass. So in the next video I will show you how to calculate for the friction force.